question. Now it's 2017 Sanskrit 1, GCE question A5. So now this question is based on simple machine. Now, before you proceed, for what we know is that a simple machine is defined as a device which makes work easy. By applying force at one point, it can be used to overcome a force at a different point. Now, there are two terms that I've actually stated in that definition for a simple machine. Now, for what we know is this: the force applied, it is known as the effort. The force overcome, it is known as a load. Now, in this case, let's go through the equation. The diagram below shows a frictionless pulley used to lift an 8,000 Newton block of concrete. Now, the term here given it is frictionless pulley. Now, if we're dealing with a frictionless pulley, at this point, we are dealing with what we call as an ideal pulley. Now, when we say an ideal pulley, we say this pulley has the efficiency of 100%. Therefore, it is not hindered by what we call as what friction. And then there is also no energy which is actually wasted. Now, an ideal pulley, which is also known as what a frictionless pulley, it has the efficiency of 100%, which also means that the mechanical advantage, it is also equal to the velocity ratio in this case. So now, in this question I've been given what is the minimum effort required to raise the block. At this point, I want us to determine the effort which is actually used to overcome the block. Therefore, for what we know is this. For us to determine this, we are going to answer this question in two ways. Now, the first one, we are going to say that mechanical advantage is equal to the velocity ratio. Since we are dealing with what we call as a frictionless pulley, therefore the mechanical advantage and the velocity ratio, it is the same. Now, in this case, what would be the velocity ratio? Now, if we're determining the velocity ratio on a pulley, you count the number of times a line passes per wheel. So now, at this point, the velocity ratio that we have here, it is 1, 2, 3, 4. Therefore, the velocity ratio here, it is 4. Therefore, the mechanical advantage, it is also at 4. Because the mechanical advantage and the velocity ratio, they are always equal if we're dealing with a frictionless pulley. Now, in this case, now, if our mechanical advantage is 4, then how can we determine our effort? For what we know is this: mechanical advantage, it is defined as the ratio. Okay, so mechanical advantage is defined as the ratio of load to effort. Therefore, since we already have our mechanical advantage, which is 4, we're going to substitute. Our mechanical advantage here is 4, which is equal to our load. The load given in this case, it is 8,000 newtons. 8,000 newtons. Divide this with our effort. We cross multiply, we balance this with 1. This by this, you have 4E is equals to 8,000 newtons. So since we are looking for the effort, we divide by 4, we divide by 4. This and that we cancel. This into that, which means our effort there, it is 2,000 newtons. Now this is the first way in which we can actually determine our effort. The other way around that we can do it. Now, for what we know is this: since we are dealing with an ideal pulley, therefore the efficiency is 100%. We can also use this formula, which we can say that efficiency is equal to mechanical advantage over velocity ratio times 100%. Therefore, since we're dealing with an ideal machine, the efficiency is what? 100%. Now, in this case, we are going to use this formula to determine our mechanical advantage. Then now we can proceed from there. Now, for what we know is this: mechanical advantage is equal to load over effort. Therefore, we are going to apply this way, which means our efficiency rate is 100%, which is equal to mechanical advantage. We're going to put x over velocity ratio here. We count the number of times the line passes per wheel. Therefore, we have the velocity ratio here, which is 4 times 100%. We pass this with 1, so which is 100% x. This by this, 100% x. This by this, we have 4. We pass this with 1. This by this, we have 100% x. This by this, we have 400%. Since we're looking for x, we divide with 100%, even here with 100%. We cancel, percent, 0, 0, 0, 0. 1 into that, therefore our 4 there it is what? 1. Which means therefore our mechanical advantage there it is 4. Now after doing this, then now we proceed. We say that mechanical advantage is equals to load over effort. We back this with 1. Let's make our effort the subject of the formula. This and this, we have MAE is equals to L. We balance with mechanical advantage, even this with mechanical advantage. This and that we cancel. Therefore, effort is equals to load over mechanical advantage. Then we say that effort is equals to the load that we have been given there. It is 8,000 newtons. We divide it with our quick advantage, which is 4. If we divide, we're still getting the same answer, which is 2,000 newtons. Therefore, our answer in this case it is B. Thank you.